This is a training video for the OSHA 1926 Subpart K regarding electrical requirements. This picture represents the typical type of conductors that one might see in a raceway or other approved enclosure. These conductors are also commonly used for grounding purposes. Here is another picture of a typical conductor material in the form of non-metallic cable. The bare wire within this assembly is used for all grounding requirements. To show the importance of grounding, here is a picture of various overcurrent and short circuit devices within a panel board. The short circuit portion on this works when all electrical systems have been grounded properly. Therefore, to ensure that all fuses and breakers work properly, correct grounding must be assured. This is a picture of a metallic panel board cover. OSHA 1926 Subpart K specifies that all exposed non-current carrying parts must be grounded. Additionally, all metal enclosures for service equipment must be grounded as well. This is a good example of both. Here is another example of a non-current carrying metallic panel board cover. The grounding requirement for this panel board and service equipment ensures that should any of this equipment, enclosures, and/or other associated metallic parts become energized, the safety devices will work properly and all personnel will be protected. Here is an example of a cord-connected metallic appliance. The OSHA requirements for all metallic appliances require that a 3-prong plug connection be supplied. This picture reveals that a 3-prong cord is being used and thus meets this requirement. OSHA requires that the path to ground be permanent and continuous. This picture represents an appliance that is connected to a dust system where grounding is not continuous. However, this system is grounded at different ends, thus meeting the OSHA requirement for grounding. The next two pictures show service equipment that is attached to a metal unistrut support, thus being part of the system. These supports must be properly grounded as well, being as they are part of this electrical system. Again, here is an example of a 3-prong cord. The middle third prong is what is attached to the equipment grounding conductor that is required by this OSHA standard. This is an example of a 125-volt GFCI duplex receptacle. A GFCI is a current leakage device that is able to detect small imbalances in current and thus give an added level of safety to a properly grounded electrical system. OSHA requires that all 125-volt receptacles at a construction site be of GFCI type. This picture shows 2 GFCIs at the top and one to the right bottom that is GFCI protected. This is part of an assembly of a temporary service at a construction site and meets the OSHA requirements. Just to summarize the electrical requirements for grounding and GFCIs at construction sites required by OSHA, all electrical systems must be grounded. The grounding path must be continuous, and all enclosures and supports must be grounded as well. Additionally, ground all non-current carrying parts. All cords must be 3-prong grounding type, and any 125-volt receptacle at a construction site must be of GFCI type. These are the requirements, in short, for the grounding as required by OSHA 1926 Subpart K.